Good morning/afternoon, everyone. I'm excited to welcome you to this presentation on advancing behavioral measurement, ensuring quality and reliability. Today, we will delve into challenges we face when observing human behavior, explore ways to enhance our measurement techniques, and look ahead to future directions that can improve the accuracy and consistency of our observations. This is a vital topic for anyone interested in understanding and measuring behavior effectively. Let's dive in. Behavioral measurement is essentially about carefully observing and recording how people act, respond, or interact, whether individually or in groups. This process needs to be done systematically to ensure we gather accurate information. The quality of these measurements is absolutely crucial because reliable data forms the foundation for drawing valid conclusions, whether in research settings or practical real-world applications. On the other hand, if the data we collect is of poor quality, it can lead to incorrect interpretations and ineffective interventions. This not only wastes valuable resources, but also damages the credibility of the studies and programs that rely on this information. So, maintaining high standards in behavioral measurement is key to achieving meaningful and trustworthy results. When measuring behavior, one major challenge we face is bias. Both the observer's expectations and the participant's awareness can skew the data, making it less reliable. Another issue is measurement error, which can happen when data is recorded inconsistently or when the tools we use are flawed, leading to inaccuracies. We also struggle with reliability. It's often hard to get the same results repeatedly, whether over time or between different observers. Validity is another concern. Sometimes the measures we use just don't truly capture the behavior we want to study. Finally, subjective reporting adds complexity. When people report on their own behavior or someone else's, their perceptions and memories can influence the information, which can reduce how objective and trustworthy the data really is. All these challenges highlight why careful design and critical evaluation of behavioral measures are so important. To enhance measurement quality, the first key step is standardizing protocols. This means using clear and consistent procedures when observing and collecting data, so everyone follows the same method and results are comparable. Next is calibration, which involves regularly aligning instruments and even observers themselves to ensure accuracy stays high over time. Comprehensive training is also essential. When observers are well trained, it helps reduce variability and bias, leading to more reliable data. Incorporating technology, such as video recording, sensors, or specialized software, can significantly increase precision and objectivity in measurements. Finally, it's important to reduce observer effects by minimizing how much an observer's presence might influence the behavior being measured, ensuring that the data reflects natural behavior as closely as possible. All of these strategies work together to improve the overall quality and trustworthiness of our measurements. When assessing measurement quality, there are several important factors to consider. First, test-retest reliability looks at how consistent our measurements are when we repeat them under the same conditions. If the results remain stable over time, we can be more confident in their reliability. Next, inter-observer reliability involves comparing the data collected by different observers. This helps us ensure that measurements aren't subjective or biased by a single person's perspective, but rather consistent across different individuals. Then, validity checks are crucial. They use established criteria to verify that what we are measuring truly reflects the intended behavior or concept. Finally, statistical validation methods come into play, where we apply various analyses to identify any anomalies or biases in the data and to confirm that our measurements are robust and trustworthy. Together, these steps help us build a solid foundation for accurate and meaningful measurement. Let's look at some real-world examples of how quality improvement has made a difference. First, in classroom research, implementing standardized coding schemes has helped researchers achieve better consistency between observers, which means the data is more reliable. Next, wearable technology has been a game changer for tracking physical activity accurately, as it reduces the common problem of recall bias where participants might forget or misreport their activities. In clinical assessments, introducing specific training protocols has effectively reduced observer drift, ensuring that behavioral evaluations remain consistent over time. Altogether, these cases highlight how deliberate, quality-focused adjustments can significantly enhance both the accuracy of data collected and the validity of its application. Looking ahead, we see several important trends shaping the future. First, automation is becoming increasingly prevalent, with more sensors and software being used to gather continuous and objective data. This allows for more precise and real-time measurement. Next, artificial intelligence is playing a growing role, as machine learning techniques help us analyze complex behaviors and detect subtle patterns that might otherwise go unnoticed. However, despite these advances, we still face ongoing challenges, such as dealing with contextual variability, meaning that behavior can change depending on the situation, and addressing important ethical considerations. Looking forward, the goal is to combine these new technologies with rigorous quality practices, ultimately improving the reliability of our measurements and making them applicable across a wider range of real-world settings.